Welcome back. In this section, we're going to be doing section 4.5, which is about the slope-intercept form of a line. So it turns out that out of all the different equations of lines, and there are a few different ones, the slope-intercept form is pretty useful. And so we're going to focus on it in this section. So first of all, what the slope-intercept form looks like is y equals mx plus b. And this is maybe familiar to you, depending on your other schooling. Here the m is the slope and the b is the y-intercept. Sometimes people say slope y-intercept form, but often people will just leave out the y. When we say slope-intercept form, though, it's the y-intercept that we're talking about. And why it's called that, both of those elements are in the equation, just to be sure that we're sure. When x is 0, if you plug that into this formula, you're going to have m times 0 plus b, and that's 0 plus b, which is just b. So the point 0b is on the graph, and that is going to be the y-intercept, and is right there in the equation. Okay, so one of the main things that we can do with a line in slope-intercept form is graph it. So we're going to try that here. It says, actually, no, I lied. This one we already have the graph. This one, we want to find the slope and y-intercept of y equals 2/3 x minus 1. So we're given that this is the graph, and we can read off the slope and y-intercept from the graph. Let's get the y-intercept first. So looking at the graph, the y-intercept looks like it is at 0, -1. Okay, and there's that, and that makes sense given the formula is 2/3 x minus 1. And then the next thing that we'll need is the slope. So starting with some point on the graph is exactly matches one of the corner points. It looks like we can use -3, -3. And then let's use 3, 1. Okay, so let me calculate the slope. So the change in y will be 1 minus -3. And then in the denominator, the change in x is, which is 3 minus -3. 1 minus -3 up top, that's 4. And then down below, 3 minus -3 is 6. And 4/6 reduces to 2/3. Notice that that 2/3 is the same as the 2/3 in the formula. Okay. So next, we don't have the picture, but that's okay. We're going to find the slope and y-intercept of y equals -4/3 x plus 1. So just reading off the formula, the slope is going to be -4/3. Y-intercept will be the point 0, 1. Okay, the +1 in the back tells us that the y-intercept is a 1. Okay. Next, we can find the slope and y-intercept of 3x plus 2y equals 12. And there's an easy way to do this and a hard way. The hard way would be to draw the graph of this by finding the intercepts or other 2 points, and then using that information to answer the question the way that we did this one, basically. The easy way is to rewrite this equation in slope-intercept form. So that's what I'm going to do. We have 3x plus 2y is 12. I'm going to subtract the 3x from both sides. And then we're going to divide by 2. So we have -3x plus 12 divided by 2. We'll separate that into 2 separate terms. That will give us -3/2 x plus 12/2, which is 6. From there, we can read off the slope and y-intercept easily. The slope is -3/2, and the y-intercept is the point 0.06. So that's not too bad. Okay. The next thing, we've seen how to graph a line using a point and the slope. In this part, we have specifically that the point is that we're given is the y-intercept. So here we're going to graph the line y equals -x plus -3 using the slope and y-intercept. So the slope here is -1. and the y-intercept is 0, -3. So let me go down to 0, -3, and then we'll use the slope. The slope is -1, so I could go down 1 and right 1, but that's going to kind of take me off my picture. So instead, I'm going to go up 1 and left 1. So up and left instead. We could do that again, up and left some more. That gives us plenty of points. So let's connect the dots. Okay. So we've graphed our line using the slope and y-intercept. Okay, here's one for you to try. We're going to graph y equals 5/2 x plus 1. So pause the video and take a minute, try this yourself, and then restart the video and see how you did. Okay, so here we have a slope of 5/2 and a y-intercept that is the point 0, 1. So I've got the point 0, 1 on the graph. And then for the slope, I'll need to go up 5 and right 2. Okay, the numerator is the change in y, so the up down. The denominator 2 is the change in x, and so the left right. We're going to go up 5 and right 2. We could go down 5 and left 2 if we wanted. Here I was looking at this and I'm thinking, if I go up 5, I need to be at 6, and that's going to kind of take me off my grid, and I don't want to do that. So I could also go down 5 and left 2. Or if you want, probably not like this, we could go up 2.5 and right 1. Okay, that also would have the same ratio. But it's nice to stay on the integer coordinates, so let's do that. Actually, if I go down 5, that will also take me off the grid. So I'm stuck doing the up 2.5, right 1 thing. Okay, so from 1, I've gone to 3.5 in the y direction, and then right by 1. Okay, so that'll take us to the line with the point 1, 3.5, and we were originally at 0, 1. Okay, you can use the slope here for a line. We'd mentioned this before, but worth repeating. The line has constant slope of 5/2. So as long as your y change divided by your x change is equal to 5/2, you can use any point on the line you like. Go up 5 and right 2, down 5 and left 2, up 2.5, right 1. All of those would have yielded a point on the graph. Okay, next we have 2x minus y equals 6 using the slope and y-intercept. So here I'm going to rewrite the equation first in slope-intercept form. So I'm going to subtract 6 from both sides and add y to both sides. So y will be 2x minus 6. That makes our slope 2, and our y-intercept, our y-intercept is going to be -6. Okay. All right, so here I'm not able to fit the y-intercept on my grid, so let me fix the grid real quick. All right, so that's better. So now we're able to fit the y-intercept at 0, -6, and then the slope, 2 is the same as 2 over 1, so I will go up 2 and right 1. So up 2 and right 1 will take us to the point 1, -4. And that will do it. 0, -6, and 1, -4. Okay, so graphing lines using the slope and y-intercept. So the next part is on how do you decide what is the best method for graphing a line. So just taking a look, If there's only one variable in the equation, then the line is either horizontal or vertical. If it looks like x equal a, where a is a number, then it's vertical and passes through a0. An example would be x equal 2. That will pass through the point 2, 0 and be vertical. If it looks like y, sorry about that. Zoom crashed on me again. So backing up just a little bit, if it looks like y equals b, where b is a number, then the line will be horizontal, like if we had y equals 7, it would pass through the point 0, 7 and be horizontal. If it's in slope-intercept form, use the slope and y-intercept, like the last couple of examples we did. If it's in the standard form, which is ax plus by equals c, then it's going to be easiest to find the intercepts. So let me give a small example of that. If you have 2x plus 3y equals 12, it's relatively easy to substitute in 0 and calculate. So for example, if x were 0 in this equation, if x were 0, we'd have 3y equals 12. That would make y be 4. And then if y were 0, we'd have 2x equals 12, so that x is 6. So I didn't write much there. So if you didn't quite get it, rewind and make sure that you understand where we're getting the 0, 4, and 6, 0 from. So if you have an equation that is in standard form, you're probably best off using the intercepts to figure that out. Okay, the next part is on parallel and perpendicular lines. So parallel is the easiest, so we're going to start there. Parallel lines, I'm going to assume everybody knows what that means. They look like that. They point in the same direction. Since slope is a measure of direction, the key fact is that parallel lines have equal slopes. So to try and decide, let's see if x minus 2y equals 4 and x minus 2y equals 10, if they're parallel or not. So to do that, I'm going to rewrite each in slope-intercept form. So the first one will be x minus 4 equals 2y. Dividing by 2, we'll have 1/2 x minus 2 is y. That means that the slope is 2. For the other one, we'll have x minus 10 equals 2y. And so dividing by 2, we'll have 1/2 and x minus 5 equals y. This one has slope 1/2. Both of those lines have slope 1/2, so they are parallel. Okay, this one's probably no, but we'll check. We're to decide if these two lines are parallel. The second one, I can tell at a glance that it has slope 2/3. It's in slope-intercept form. It makes it very easy to figure out what the slope is. For the other one, we have 2x plus 3 equals 5y. Dividing through by 5, we'll have 2/5 x plus 3/5 for y. This one, the slope is 2/5, which is, of course, not the same as 2/3, so these are not parallel. Parallel lines have equal slopes. If they don't have equal slopes, they're not parallel. Okay, perpendicular lines intersect at right angles. So like your floor and your wall are perpendicular to each other, hopefully. They intersect at right angles, or a 90-degree angle, if you like. The algebraic criterion for deciding if two lines are perpendicular or not is a little trickier. Suppose that two lines have slope m1, m2. If they're perpendicular, that means that the product of the slopes is -1. Or equivalently, one has -1 over the other one's slope. So just some examples. If you had two lines with slopes of 3/4 and -4/3, that would be -12 over 12, which is -1. So those would be perpendicular. If you had one with a slope of 4 and one with -1/4 for a slope, those would be perpendicular. If you had one with a slope of 2 and one with a slope of 1/2, not perpendicular. In addition to being reciprocals, they have to also be opposite in sign, which makes sense if you think about it. If two lines are going to be perpendicular, one's got to go up, one's got to go down. So one has to be negatively sloped and one has to be positively sloped. Okay, so just a yes or no question. We're to decide if 5x plus 4y equals 1 and 4x plus 5y equals 3 are perpendicular or not. So to do that, we're going to rewrite each in slope-intercept form. So for the first one, I'll subtract 5x from both sides, then divide by 4. So that will give us y equals negative 5/4 x plus 1/4. That one's slope is negative 5/4. Let's take a look at the other one. 5y is negative 4x plus 3. Y is negative 4/5 x plus 3/5. This one has slope negative 4/5. And both are negative. They're not opposite in sign, so they're not perpendicular. The number piece is reciprocals, 5/4 and 4/5, but that's not enough. They have to also be opposite in sign. Okay, let's hope for the best on this one. This one, the slope is negative 3. For the next one, we have, push it to the other side. We'll have x minus 4 is 3y. So then 1/3 x minus 4/3 will be y. This one has slope 1/3. 1/3 and negative 3, those would multiply to negative 1. And so that means that, yes, the two lines are perpendicular. Okay. All right, next, a story problem, and then we'll be done with this section. Okay, the story here is the cost to rent a car is C, which is equal to 0.32 M plus $15 per day if M miles are driven in a day. So here the M stands for number of miles. The M is not slope, M is the number of miles driven, and C stands for the cost in dollars. Okay, and then we're just to answer a few questions about it. Find the cost to drive 0 miles in 1 day. Okay, that would be 0.32 times 0 plus 15. That's 15. It will cost $15. That's the vertical intercept. Okay, find the cost. We did that. B, what are the slope and y-intercept? The slope is 0.32, and the y-intercept is 15. Okay, and the slope is in dollars per day. No, dollars per mile, sorry. Dollars per mile. The $15 is in dollars per day. Okay, the cost to drive 400 miles in a day. There we'll set the cost equal to 400 and solve for M. Okay, so that is the setup. So we'll have 385 is equal to 0.32 M. And we'll divide our 385 by 0.32 to find the number of miles. So let's do that. And that's about 1,203. That didn't make any sense. I totally did that wrong, didn't I? Here, we want to know the cost to drive 400 miles. I didn't do that right. I made 400 equal to the cost, not the number of miles. So no, that's definitely the wrong thing to do. The M that was supposed to have been the 400. So sorry about that. I was not paying attention to what I was doing. Okay, so the 400 is the number of miles we're driving, and we want to know the cost for that. Okay, so let's do that. 0.32 times 400, that's $128. So we'll add to that the 15. And so that's $143. Okay. All right. So sorry about that. And that takes us to the end of this section. Let me know if you have any questions, and have a great day.